Mini lesson 3D. Solve for complex solutions. We have 4 different solutions for powers of I. I to the 0 power is 1. I to the first power is the same thing as the square root of a -1, also known as I. I to the second power is -1, and I to the third power is -I. At I to the fourth power, the cycle repeats since I to the fourth power is 1. These same 4 solutions will cycle through for all of those I powers. To find I to the nth power, you want to evaluate mod n comma 4. The answer will be one of 4 powers, 0, 1, 2, or 3. Use this to determine which I to the nth is equivalent to. We'll look at this with an example. Simplify I to the 75th power. When it says mod of a number, comma 4, it just means that you're going to find the remainder. We do 75 divided by 4. 4 goes into 7 one time. 1 times 4 is 4. Subtract, you get 3. Break down the 5. 4 goes into 35 8 times. 8 times 4 is 32. You get a remainder of 3. Mod of 75 comma 4 is equal to 3. That means that I to the 75th power equals I to the third power, which equals -I. Factor out the greatest common factor, the GCF. 2 and 8 square root 2. The GCF of these is 2. We could factor out the 2, and you're left with 1 plus 4 square root 2. 6 minus 16 square root 3. You could divide each of these by 2. 6 divided by 2 is 3, and 16 divided by 2 is 8. What's left inside the parentheses, we have 3 minus 8 square root 3. On the third one, we could divide out a -4. -8 divided by -4 is 2, and 28 divided by -4 is a -7. We have 2 minus 7 square root 10 left over inside the parentheses. Simplifying square roots. When you simplify square roots, you want to try to factor out the following perfect squares: the square root of -1, the square root of 4, the square root of 9, the square root of 25, and the square root of 49. You could also factor out other perfect squares, but these are the ones that show up the most. On the first one, we have the square root of -44,100. It has a negative, so we can factor out a square root of -1. Let's see what else we can factor out. Let's try 4 first. Okay, this one works. And the square root of -1 is I. Let's see what else we could factor out of this. Let's divide this by 4. Okay, that doesn't work. It gives you a decimal. Let's try 9 this time. Okay, that one would work. The square root of 4 is 2. All right, let's see if we could divide out another 9. It looks like we cannot since it's a decimal, so let's try it again with 25. We can, it's 49. The square root of 9 is 3. Bring down the 2 and bring down the I. From here, the square root of 25 is 5, and the square root of 49 is 7. We'll multiply all of these together. 5 times 7, we get 35. 2 times 3, we get 6. And then we're going to have 6 times 35. 210. 210i would be your simplified square root. In this case, it was a perfect square. Let's do a smaller number now. They're the square root of -180. We take out the square root of -1. That's I. 180. We could factor out a 4 since 4 goes into 80. And then that would be 45. For 45, we could factor out a 9. Square root of 9 times square root of 5. Bring down that 2, bring down the I. And then we have I times 2 times 3 times the square root of 5. 5 can no longer be reduced, so we're going to keep that in the square root. 2 times 3 is 6. 6i square root 5 would be your simplified square root. And then we have the square root of -392. Factor out that -1. It looks like we can factor out a 4. It's 98. Square root of 1 is equal to I. So then we have I times 2. 98, you can factor out a 49. And that gives you 2. So then we have I times 2 times 7 times the square root of 2. We can't reduce 2 anymore, so we have our simplified square root of 14i square root 2. Simplifying fractions. We have an integer followed by an irrational number divided by another integer. To simplify this fraction, we want to find what all three of the integers could be divided into. all three of these numbers, 2, 8, and 2, are all even. We could divide all those by 2. Then we get 1 plus 4 square root 2 over 1. You don't need to write the 1 since these numbers divided by 1 would still be those numbers. This would be your simplified fraction. 1 plus 4 square root 2. On the next one, 4, negative 18, and negative 6 are all even again. You could divide those by 2. So then we have 2 minus 9 square root 30 over negative 3. Now we usually do not want negatives in the denominator, so we're going to change the signs of everything, also known as divide everything by negative 1. Negative 2 plus 9 square root 30 all over 3. And then we have negative 6 plus 21 square root 6 all over 12. For these, we could divide out a 3. We get negative 2 plus 7 square root 6 all over 4. One thing you also want to check before you divide out the numbers is that the square root is simplified already. 2, 30, and 6 are all reduced square roots. Let's go to the next page of this. We have verbal steps and algebraic steps for solving a quadratic equation by taking the square roots. We have our vertex equation first, a parentheses x minus h squared plus k equals 0. Subtract the number by itself from both sides, divide by that leading coefficient, square root each side. You'll put a plus and minus sign in front of the square root that you're solving for. The square and the square root will cancel, and then add the h to the other side. Let's look at these examples. Solve by taking square roots. We have x squared plus 9 equals 0. In this case, it looks like we only have a k. There's no h or a. So we're going to subtract that 9 from each side. And the other step that we need to do is take the square root of each side. Put a plus and a minus in front of the square root. Now the square root of negative 9 is a perfect square. X is going to equal plus or minus 3i. On the next one, we have another step added to it. We have 5x squared plus 1 equals negative 599. Subtract 1 from each side. 5x squared equals negative 600. Divide each side by 5. X squared equals negative 120. Take the square root of each side. We're going to write a plus and a minus in front of the square root. 120 can be reduced. Let's do that off to the side. We have 2i square root 30. X equals plus or minus 2i square root 30. Let's look at the next one. 7 parentheses x plus 4 squared equals negative 819. Let's divide each side by 7 first. And then we're going to take the square root of each side, plus and minus. X plus 4 equals plus or minus the square root of 117. Let's see if we could divide out any of those perfect squares. It's an odd number, so we cannot divide out 4. We could divide out 9, though, and an I. So let's do that off to the side. We have 3I square root 13. Subtract 4 from each side. And then we have x equals negative 4 plus or minus 3I square root 13. All right, this last example on this page has an A, an H, and a K. We're going to use all the steps from the top of the page to solve for this one. Subtract 36 first. Then divide by 3. We get parentheses x minus 1 squared equals negative 12. Take the square root of each side. Put a plus and minus in front of the square root we're solving for. Let's simplify the square root of negative 12. We get x minus 1 equals plus or minus 2I square root 3. Add 1 to each side. X equals 1 plus or minus 2I square root 3. On the last page, we're going to solve quadratic equations using the quadratic formula. X squared plus 6x plus 50 equals 0. First, identify A, B, and C. It's the coefficients of each of the terms of this trinomial. There are 1 x squareds here, so A is equal to 1. B, there's 6 of those, so we're going to write 6. And then C, our constant, is a positive 50. Let's plug these into the formula. All right, we have B, so it's negative 6 plus or minus 6 squared minus 4 times 1 times 50, all over 2 times 1. Let's simplify this sum. Negative 6 plus or minus the square root of 36 minus 200, all over 2. From here, let's find the discriminant. "36 minus 200 is negative 164. That means we're going to have two complex solutions here, two imaginary answers. Let's simplify that square root off to the side. We take out the -1. Looks like we could take out a 4. And so we have 2i square root 41. Let's rewrite this. -6 plus or minus 2i square root 41 all over 2. Now let's simplify our fraction, like on the first page. These are all even numbers. Divide out 2. -3 plus or minus I square root 41. Those are your two solutions for x. Let's look at the next one. X squared minus 8x plus 20 equals 0. Identify A, B, and C. The coefficient of x squared, there's no number there, but there is an x, so there's one of them. The coefficient of b, the middle term, is -8, and the constant coefficient is +20. Let's plug these into the formula. We have -8 plus or minus the square root of -8 squared minus 4 times 1 times 20, all over 2 times 1. All right, let's simplify this a little bit. 8 plus or minus the square root of 64 minus 80 all over 2. Let's find the discriminant of this. 64 minus 80, we have -16. 8 plus or minus the square root of -16 over 2. -16 is a perfect square. It's 4i. 8 plus or minus 4i all over 2. Simplify the fraction. They're all even numbers. You can divide out 2. X equals 4 plus or minus 2i. And then we have this equation, -3x squared plus x equals 5. We don't have it as equaling 0, so let's change it. Subtract 5 from each side and rewrite it. -3x squared plus 1x minus 5 equals 0. Identify A, B, and C. A is -3, B is a +1, and C is -5. Let's plug them into the quadratic formula. -1 plus or minus the square root of 1 squared minus 4 times -3 times -5, all over 2 times -3. Simplify this. -1 plus or minus the square root of 1 minus 60, all over -6. We'll get -1 plus or minus the square root of -59 all over -6. The discriminant is a -59. we could change that to an I square root of 59. Let's divide each of these numbers by -1. X equals 1 plus or minus I square root 59 all over 6.